Now, in the previous class, we did this lab. You remember, we were not having any BGP configured on this router DNC. But we were able to form an IBGP relationship between B and E. Not only that, we saw E giving a route to B and B distributing it to A. Likewise, A's route was given by B to E and E was distributing it to F. This all happened, it is because of TCP. This is TCP protocol. So BGP can form neighbor with the remote device if there is an IP path, if it is pingable, if it is reachable. To provide reachability, what do we have? OSPF. OSPF is already running within the organization, within the autonomous system for every destination within the autonomous system. So B and E can ping each other. Already they both can ping each other. They can ping each other, no? So using that reachability, that is what I mean IB path. Between that loopback of B and E, you remember yesterday we were using loopback, and I also used the command update source. So using this, they ping each other. Okay, now I'm going to make it fast and quick and short. We are told that it is not recommended to do redistribution. Can someone say why redistribution is not recommended? Why redistribution from BGP to OSPF and OSPF to BGP is not recommended? Because this is not recommended, because we don't recommend, we were doing IBGP. That's the reason why we need to do BGP peering within the autonomous system. What is that reason? Quick, please. Think till. What is the problem of recommendation?
Problem in redistribution?
What?
The problem in redistribution you are asking?
Yeah. Problem in redistribution. Why it is not recommended?
The reason, sir, what I say is, sir, because if we do IBGP, in that case, if we do redistribution, we cannot use all BGP attributes to manipulate the routes.
Okay. Next.
So in that case, sir, scalability will be different, sir.
Yeah, next.
Convergence.
Next.
So the question is why we shouldn't run IBGP inside the OSPF area, right?
You see, redistribution is not recommended because when you redistribute, we mix the external network with the internal networks. BGP is bringing the networks that belong to different autonomous system. And when you redistribute, our internal and external get mixed. And when you redistribute back from OSPF to BGP on the other side, even our internal network will be advertised. we don't advertise the internal private networks. So redistributing is not good. Mixing the private and public is not good. BGP is taking care of those private networks, public networks. OSPF is taking care of those private networks within the organization. So redistribution is not recommended because you are going to mix the private and public, which is not at all acceptable in the real network. Next, another reason what you said is correct. You said like redistribution, when you redistribute from BGP to OSPF, all the attributes will be lost, and there is no.
Yes, sir.
And there is no attribute for those routes, then there is no point of running BGP anywhere. If you don't have attribute, then why you need BGP? So attributes are very important. To preserve the attributes, I should not redistribute. I need to allow BGP itself to carry wherever the route needs to go. That's why we are using BGP itself between E and B and E to maintain the originality. Now, if you have decided to have IBGP, there is a consideration need to be done. Number one consideration is don't redistribute. Secondly, look at this. Your IBGP need to be full mesh. Our IBGP peering need to be full mesh, not partial mesh. What does that mean? Forming IBGP between B and D, B and C, B and D and B and C, and then D and E, and then C and E is not enough. You also need to form neighbor with E and B, D and C. That is full mesh. Full mesh is forming neighbor with everyone. Partial mesh is just forming neighbor only with the physical neighbor. Listen here, look at this picture. There is no BGP update sent between B and E because B and E are not neighbor. E is neighbor to D and D is neighbor to B. Mute please. Mute please. Even though E and D is neighbor, D and B is neighbor, the route given by B to D will not be forwarded by D to E. D will not forward. See? Route learned via IBGP or never propagated to other IBGP peer. So, they need to be fully mesh. This is what called as BGP split horizontal. This rule will not allow. So what we do is, for the route updates to go here, we also form neighbor with E, so that B will give an update to D, another unicast packet update to E and C. Don't forget this. Route learned from IBGP or never propagate to another IBGP. For this reason, you need to have full mesh. Please tell someone, if I have 6 routers, how many IBGP neighbor I will have? See, here we have 4 routers. So how many IBGP neighbor, not EBGP, forget about EBGP. How many IBGP neighbor I should have in this scenario? If I have 4 router, how many IBGP neighbor I should have? Sam.
3.
3. If I have 6, how many neighbors I'll have? How many IBGP neighbors I'll have?
5.
Yes. That many IBGP neighbors you should create. Alright, so that is what called as full mesh. Now you may have a question in your mind, like, then you have decided to run BGP on all the device. Can we replace with BGP with this OSPF? Can we remove this OSPF? No, you should not remove. BGP is simply carrying the external routes. They don't care about internal routes. Internal routes is taken care by OSPF. So you should not remove. You should not remove. So full mesh is the solution. At the same time, you cannot remove OSPF. OSPF is required for those internal networks, those private networks within the autonomous system. BGP is needed for carrying those external networks from one end of the autonomous system to other end, so that it can be redistributed to the neighbor autonomous system. Please ask me a question if you have. The 2 lines at the bottom is what called as IBGP split horizon rule. IBGP split horizon rule says route learned via IBGP are never propagated to other IBGP. For this reason, when you make full mesh, each router will get an update. So let me repeat. When B sends an update to D, D will not forward it to E. So if you have direct neighborship with E also, so you will send a copy of an update to D as well as to E as well as to C. Full mesh is recommended. Now we must run BGP on all the routers. If you leave these 2 routers, what is the problem? See, in yesterday's class in the lab, I tricked you. You did not see that. You did not notice that. What is the trick I used? I did not enable BGP here and here. We just learned it needs to be full mesh. We need to enable BGP everywhere. This is correct. When you form BGP only between B and E, update will be given to B, and B will also give update to E. No doubt. And see, whatever A gave to B, B gave to E directly, but D don't know about it, C don't know about it, and E will give it to F, and whatever F gives to E, E will give to B, and B will give to A. C and D won't learn it. C and D won't learn it. We saw these things, but you did not focus this. This is how it was yesterday. We saw the route of F on A, route of A on F, but I did not ping. That is the trick I used. I did not ping. If I would have pinged, the ping would have not been successful. Why the ping won't happen? Because the packet have to somehow go through this C or D. But these 2 guys do not know about the route. So the packet will come up to B, and B will say, I will send it to E. To send it to E, it will try to push it via C or D. When it comes to C, there is no route. So the packet gets dropped. for this reason, you need to have full mesh. We need to have full mesh. This is the solution. I'll do and show you this now in some time. So, redistribution is not a solution. You need to enable IBGP on every router within the autonomous system. Even if you enable IBGP on all the routers within the autonomous system, even though you enable BGP on all routers within the autonomous system, we need to make sure it is fully mesh, meaning everyone has got peering configured with all other. As you said, if you have 6 routers, we need to have 5 IBGP peerings. 6 IBGP routers, 6 routers within an autonomous system, then 5. If you have 100 routers, 99 peering. So this is what we had yesterday. And you can see R1 showing the route of R6. Wait some time. You will see the route also here. Show IPBGP summary. Here, this has got neighbor with router 2. Router 1 is forming eBGP neighbor with router 2. How I know it is eBGP neighbor? See, my local autonomous system is 10. Router 1's autonomous system is 10. This neighbor's autonomous system is 20. So this is eBGP neighbor. The neighbor is up for 38 seconds. Now it is not 38, it is 1 minute 5 seconds. Yep. And let us also check the same on R5. Show IPBGP summary. R5 is not having neighbor with R6. Maybe we did not save some configuration in the previous class. That's the problem. We did not save some configurations, meaning neighbor with R6 is not seen here. No issues, we'll fix it. Router 6, show IPBGP summary. So router 6 is configured to form neighbor with router 5, but on router 5 I don't have it. So I'm just correcting what we failed to save yesterday. Right now it says never come up, it is idle, but soon it will come. Yeah, it has come, you see. Idle is gone, now it has become 0. 0 means I have not learned any prefix. Prefix received is 0. Means from router 6 so far I have not learned any network. On R2, also we have one IBGP neighbor, one eBGP neighbor, but so far no prefixes learned. Maybe we have not advertised. Let's go and check R1 first. Show run section router BGP. See, we are not advertising the network 11111. To advertise the network, what we need to do is we use network command. Network 1.1.1.1 mask. Next. and R6. Network 6.6.6.6. So we have advertised, I'm expecting router 2. Earlier it was 0 prefix received, but now it says I learned 1 prefix from all this neighbor. From router 1 what it might have learned? 1.1. From router 5 what it might have learned? 6.6.6.6 coming from router 6. Let's check. For that you just remove the summary and hit enter. Show IP BGP. Look at this. It says I have learned 1.1.1.1 from router 1, which is coming from autonomous system 10. And I'm learning 6.6.6.6 from autonomous system 30. Whose IP address is this? This is the IP address of the next autonomous system, not the next router. Even though this is given by R5, it shows the R6 address because R6 is what? The next autonomous system. BGP is autonomous system by autonomous system routing protocol. So autonomous systems are identified, not the routers. Now, is this next hop a pingable address? No, because we are not running OSPF here. So let us run OSPF so that it will be a pingable. Into interface J01/0 IP OSPF 0. Likewise on R2 interface G1/0. You may also use static route if you want. Okay, now let us check the BGP table. Show IP BGP summary. You see right now the same 1.1.1 network. I want to see whether now it is saying this greater than symbol. Earlier when I was checking, I was not seeing this greater than symbol. If you don't see greater than symbol, it is not best. You need to see the greater than symbol. Look at this. There was no greater than symbol. And it was not best. So it will not use it if it is not best. Now we have the greater than symbol because this address, earlier it was not pingable, but now it is pingable. Wait and see. Sorry, the network is pingable. You need to have the route in the routing table. Let me show you the route in the routing. Show IP route for this. See, it says I know the route, though it is not pingable. I know the route. You need to have a route. The next stop need to be a reachable one. I can go either router 4 or router 3. Now, if I'll check the routing table, show IP route BGP, please understand this. The routes that are learned from IBGP will have administrative distance 200. The routes that are coming from EBGP will have administrative distance of 20. So router 2 knows about this 1 network and 6 network. What about router 3? Router 3 also, no. Why? I'm not running BGP there. That's why. What about router 4? Router 4 do not know about this network. But router 5 knows it. So the problem is, even router 1 and 6 knows it, but the middle router 3 and 4 don't know it. Router 1 knows about 6.6.6.6. Likewise, router 6 knows about 1.1.1.1. But when you try pinging, the ping won't go it will go up to 5, and after 5 it will not go to 2 because it has to go via router 3 or 4. 3 and 4 do not know about this route. This won't happen because there is a black hole. Router 3 and 4 do not know about this network. See, it goes up to 5. After 5, you don't know where to go. Router 3 and 4 is not giving any ICMP reply for this trace. So, what's the solution? Make it fully mesh. So, I'll go to router 2 and form IBGP neighbor with the other two neighbors. Neighbor 3.3.3.3. Remote AS is same 20. I need to source it with loopback 0, no? Update source loopback 0. I told you in the previous class, whenever we have redundant paths, we should use loopback interface. Let's say update source loopback 0. Fine. Likewise, I have to go to router 5. Before I go to 5, let me finish on 3 and 4. On router 3, I need to say router BGP 20. I got a neighbor called 2.2.2.2. Remote AS is 20. Update source. I got another neighbor called 5.5. Remote AS. Oh my god, I put 10. That's wrong. I'll correct it. And update source loopback 0. Fine, this router 3 is ready with BGP. What about router 4? Yep. Now let us move on to the last router and make this as full mesh. Right now, show IPBGP summary. You don't have more than 2 neighbors. We need to form neighbor with other 2 IBGPs, router 3 and 4. That's what we are doing. Alright, so you will find now for router 5 you'll see 4 neighbors, 3 IBGP neighbor, 1 ABGP neighbor. Show IPBGP summary. You see we got 3 IBGP neighbors, 20 20 20, router 2, 3 and 4, and this is EBGP neighbor. Now let us go and check whether we are able to trace route now. If you trace, now it will work. Look at this. It works. It goes to 5, from 5 it goes to 4, and 4 knows the route now. 4 knows the route. That's why the packets are now sent to router 2. Earlier it was not knowing. As a result, we were not able to ping. That is what this page explains. This page. When you don't have BGP on D and C, the route will get discarded. The packet will not be forwarded. So that we have overcome by making it as full mesh. Yep. So router 3, show IP route BGP. This also has got routes. Those external routes. See, BGP is carrying only those external routes, whereas OSPF takes care of internal routes. See, you don't find 111.1.1.6.6.6.6.6 here. You see it only in BGP. So they do their own work. So you should not replace this BGP with OSPF with BGP. OSPF is doing different job, BGP is doing different job. And the other point that we learned is it needs to be a full mesh. Meaning every router directly connected, the routers that are not directly connected, they all should form IBGP neighbor. Yeah, right. So do this lab before you come next class. Do this lab successfully. You should be able to ping from here with this. Right, you should show me this. You should do and then show me. You can use anything like GNS3 or EV or Wireshark, packet tracer, whatever you have, do it and keep it ready on Monday. I want to see these things that you have done. Use this previous class video and this class video to complete this task. If you have any question, you may ask now.